Problem number 1. 1209 plus 69 plus 53 must be added to the total. The problem requires that we add the numbers together. Write down the first number, 1209. Next, write 69. Place the ones digit under the ones digit. So we're going to write 69. This is 69. This is the ones digit. It will go under this, which is the ones digit. And of course, we are going to label the digits so that we can determine the ones digit different from the tens digit. Also, we have the hundreds digit and the thousands digit. So for 69, the 9 is the ones digit, so we place that under the ones digit, or we place that in the ones column. Place the tens digit under the tens digit, so the 6 in 69 means 6 tens. It goes right there under the tens digit or in the tens column. Write 53. Place the ones digit under the ones digit as usual, so the 3 goes first in the ones column. Place the tens digit under the tens digit. Now we are going to add the numbers. So let us add the numbers. Add the numbers in the ones column first. So that is the column that has the digits that represent ones. And all of those digits are going to be added. So we are going to have 9 plus 9 plus 3. That is equal to 21. So what do we know now, Jerry? Yes? Write the 1 in the ones column and carry 2 to the tens column. That's very nice, Jerry. So let us carry the 2 to the tens columns. What do we do next? Next, add the numbers in the tens column. So we're going to add those digits that are in the tens column. 2 plus 0 plus 6 plus 5. Notice there's a little 2 at the top. Where did that come from? Jerry, where did that 2 come from? Yes, of course, it was carried from the ones column. When we added the 9 plus the 3, we got 21. And the 2 was carried from the ones column. And now we have that 2, which is that little number that we have right there at the top of the tens column. So let us add those numbers. So we have 2 plus 0 plus 6 plus 5. And we have it right here. That is equal to 13. So what do we do? Write down the 1. Let us see what we do first. Is that what we do? Write down the 3. So it is 13. We have 13 right here. So we're going to write the 3 down. So let us do that first. Right. So we write the 3 down. And what do we do with the 1? Right. We carry the 1 to the hundreds column. So what do we do next? We are going to continue to add, aren't we? Of course we are. So add the 1 and the 2 that we have there. And the answer is 2 plus 1 is equal to 3. So write down the 3 right there. And there is no number to carry to the thousandth column. So what do we do? Yes, Jerry Lewis, what do we do? Well, there is only one number in the thousandth column, and it is written down also. So we are adding, but in the thousand, we have nothing in the thousands column right here to be added to the 1. So it's just this 1 that we have in the column, and it is placed right there. Good. So that is our answer. The answer is therefore 1,331, and our choice is A. That's very good. This problem says add together. So let us add. The problem says add together, and we are going to do just that. We are working with dollars, but we do not need to write the dollar sign as yet. Write down the first amount. Jerry Lewis, can you tell me how we are going to add these numbers? Okay. Yes. Yes, that's very good. We are going to write the point. We are going to put the point under the point, and that is going to be a guide to us. So in this problem that we are going to have, the points must be always under the other one. We are saying that we are aligning the points together. So let us do that. For the second number, write the point under the point of the first number. Good. Write the numbers on both sides of the point. So we are writing this number, $4.72, which is actually 4.72. The point goes under the point, so the 72 will be written right here, just as it is written after the point that we have right there. Good. And the 4 will be on the other side. So we are going to do that for the other number, and we are going to put the point right under the 2 points that we have there already. Good. Write in the numbers on both sides of the point as usual. So we have this number that we're going to be writing, 5.20. So let's do that. We put the 20 right there on the right hand side, and of course the 5 is going to go right over there on the left hand side of the point, just as it is in the number that we have there. So Mr. Lewis, what do we do with that number, 8 cents? What do we do with 8 cents? Shrugging a shoulder? That's not good enough. Let us go on with the program and see what is done with that 8 cents. 8 is given in cents. 100 cents makes $1. We will divide 8 by 100. Okay, that's what we are going to do, Jerry. When dividing 8 by 100, we desire to move the point 2 places to the left. Where is the point? In a whole number, no visible point is there. So where do we consider that the point is? In all whole numbers, the point is assumed to be at the right. So let us put that point right there on the right hand side, where the point is expected to be in all whole numbers. Let us now move the point 2 places to the left. There is only 1 digit, so a 0 will have to be included in order that the point may be moved a second time. Jerry, we have to put another 0 right there. We have 8, and 8 is a single digit. So in order that we can move the point 2 places, we have to include a 0, and that 0 is going to be included right at the correct spot. What's the correct spot? Okay, we'll see that in a minute. So that's the beginning, and let us move our point 2 places to the left. See that, Jerry? After we move 1 place, what happens? We need to move another place, so a 0 is placed at the appropriate position. Do you want us to do that again? All right, well, let's go. One. Good, so we have 2 places, and that's what we have done. We may put a 0 at the front, so we may write a 0 in front of the point, right there. And that 0 tells us that there is no whole number part of that problem. So that problem is a decimal fraction 0.08. So we are going to write that 0.08 under the numbers, and then we are going to continue with our addition. So let us continue. Right. And we have the 0.08 also included as a part of it. So let's see what we do now. You know we have done that already. So what do we do first? Apart from putting the line, we need to put the line, yes, but what else do we do? Add the digits in the hundredths column. So let's do that. That's our hundredth, not hundred, not hundreds, hundredths. Right. Good. So 0 plus 2 plus 0 plus 8 is equal to 10. So what do we do? Let's see. Write down 0 and carry 1 to the tens column. So do that. Let's do that. We put 0, and then if we put it here, it's going to be in the word tens, and it's going to look a little bit jumbled. So let us see how that is done. Oh yes, we move the tens and we put the one that we need to carry right there. So that's very good. And if we need to put something else somewhere, we may move, say for example, the ones in order that we don't have a jumble of numbers and letters till we do not know what we are doing. So let us move on to the next one. Add the digits in the tens column. So we're going to add the digits in the tenths columns. The tenths column is this one, not tens, but tenths. Right. Good. So let's do that. We're going to add those. What are they? 1 plus 5 plus 7 plus 2 plus 0. What is the answer? Of course, Jerry, the answer is 15. I have it right on the computer screen. You didn't have to work it out. But if you worked it out, you would have realized that 15 is correct. Next time, Jerry, I will not work it out. I'll ask you first. So we are going to write down the 5, and we are going to carry the 1 over to the ones column. And what do we do next? Continuing to add. Put the point under the point. That's very good. Do not forget that we need to put the point also. So we have placed all of these points one under the other. And also in our answer, we need to put the points under the points also. That's very good. Add the digits in the ones column. That's what we are going to do next. So 5 plus 1 plus 4 plus 5. Or we may take the 1 first. 1 plus 5 plus 4 plus 5 plus 0. And that is equal to 15 again. So what do we do? Yes? And after we write that 5 down, what do we do? Good. We are going to carry the 1 to the tens columns. Not the 10th, but the tens column. So write down the 5 and carry 1 to the tens column. That's what we are going to do. That's very good. And finally, add the digits in the tens column. We only have 2 of them. 1 plus 2. 1 plus 2 is equal to 3. You are very quick to say 3, Jerry. Everybody can add 1 plus 2. No surprise there. We may now declare our answer using the dollar sign. Remember, everything is given in dollars and cents. Now we are going to use that dollar sign right there. So we are sure that our answer is $35.50. And what option is that? Option A. Well, go ahead and mark it. Good. What is 2 hundredths written as a decimal? Or 2 out of 100 written as a decimal? And we have our 4 options as usual. And let us see which one is correct. 2 hundredths means 2 divided by 100. So let us divide 2 by 100. Or we may say, when dividing 2 by 100, we desire to move the point 2 places to the left. I think that we have done something like that before, but let us do it again. So there we are. All right now, Mr. Jerry Lewis, I need you to tell me exactly what to do. We are going to move the point. What do we do first? Right? Yes. So the point in a whole number is considered to be at the right. That's correct. So let us put that point right at the right-hand side of that number. There. What do we do next, Jerry? Yes, Jerry, we are going to move 2 places to the left. But how can we move 2 places, Jerry, when we only have 1 digit? What do? We have 1 digit and we need to move 2 places. So what do we do? Very good. Now that you have remembered. So while moving our point, we need to include another 0 in order that we may have the 2 decimal places, Jerry. That is very, very, very good. You are a very alert assistant today, Jerry. So let us now move the point 2 places to the left. There's only 1 digit, so a 0 will have to be included in order that the point may be moved a second time. So that's where our point is. So let us move it 2 times. And of course, the second time, a 0 is included like that. Right, and we are going to move our point. And as usual, we may place a 0 in front. So we may write a 0 in front of the point like that. So our answer is 0.02, and this represents option A. Number 4, what is 2/5 written as a percentage? What do we do with that 2/5 as a percentage? Jerry, what does percentage mean? Percentage means out of 100. Good. So we need to multiply 2/5 by 100. So write that. To write the fraction as a percentage, we need to multiply the fraction by 100. Very good. How do I know that you're smart, Jerry? When you say something, I see it on the screen. When it comes up on the screen, after you have said it, then I know that you're very smart. So ensure that when you say something, I don't see something different coming up on the screen. Else, what's the opposite of smart? Okay, that's what you'll be. So 2/5 or 2/5 to be multiplied by 100. Of course, 100 may be written as a fraction, and that is equal to 100/1. So let us put 100/1 instead of just writing that 100 all by itself. Good, so 2/5 multiplied by 100/1. So we may use reduction of fraction. So we're going to reduce the fraction, and by doing that, the expression will be simplified. So how do we reduce a fraction? We have to find a number that can go into one number that is here, and that same number can go into one of these numbers down here. Of course, we are going to choose 105. What number can go into 100, and that number can also go into 5? That number is 5. So we're going to reduce the fraction by 5, like that. And we're going to say 5 into 100 is 20, and 5 into 5 is 1. So 5 will go into 5 one time, and 5 will go into 100 20 times. Good. Multiply the numbers in the numerator. So when we do that, 2 multiplied by 20 is equal to 40. And when we multiply the numbers in the denominator, 1 multiplied by 1 is equal to 1. So we are going to have 40 over 1, or 40 divided by 1. So what is 40 divided by 1? Everybody can divide by 1? Jerry? Of course. Don't disappoint me now. What is 40 divided by 1? 40, good. Any number that is divided by 1 gives the same number as the answer. So any number divided by 1 is equal to the same number. The answer is therefore 40%, and this is option D. Right there. Jerry, you're a good assistant so far. Keep up the good work. What is 94 minus 49 rounded to the nearest 10? So let us see how we round that number to the nearest 10. 94 minus 49. First, we subtract 49 from 94. Is that too much to ask? No. What is the answer, Jerry? Oh, you don't want to supply an answer yet? You want to some time to work it out? All right, take your time. While you are working it out, I will work it out. Ensure that the answer that I get is the same number that you get. Okay. We say 4, subtract 9. We cannot subtract 9 from 4, can we? Do not shake your head, Jerry. Answer. Can we subtract 9 from 4? Good. No, we cannot. Because we cannot, what do? We go to the tens column and rename the 9. So we cannot take 9 from 4, so we go to the tens column and rename the 9. That becomes an 8. So what are we going to do? Put the 1 right there. The 1, so we take 1 from here, and that's 8. Then we put the 1 right here. However, what do we say? When renaming 9, 1 is subtracted from 9, and we are left with 8. The 1 taken away from 9 is taken to the ones column, where it is 10 times its value. It is combined with 4, and the sum is 14. So now we are going to say 9 from 14, or we're going to say 14 take away 9, and that gives 5. That goes right there. And what do we say next? Subtract 4 from 8. The answer is 4. Right there. We will now round 45 to the nearest 10. So we are required to subtract 49 from 94. So 94 subtract 49, and we need to round the number to the nearest 10. So we are going to do that. Okay, let us go right back and see. The answer that we got is 45, so we need to write 45 to the nearest 10. So let's go. So let us take the steps to round 45 to the nearest 10. That's your 45. Good. We have to include the labels. Not that we have to include the labels. The labels are included that you may see and understand exactly what I'm saying. And so that at the end, I don't want to hear you, Jerry, saying that you do not understand. How are you saying that you understand already? And I haven't finished the problem? Wait until I'm through, then you tell me if you understand. Okay? Oh, good. So we have the labels right there. The 4 is representing 4 tens, and the 5 is representing 5 ones. So we're going to round that to the nearest 10. So when rounding to the nearest 10, identify the tens digit. Sure you can, Jerry. It is identified for you already. And besides, even if it were not identified, you shouldn't have too much problem doing it anyway. Nice. So that's your tens digit. We then examine the digit immediately to the right. That's how we round. So we identify the digit that we need to round to. Right? And we put a finger on it. Our finger cannot go on the computer screen, Jerry, so we have to use an arrow. Good, so the arrow is there identifying the digit. So don't put your finger on the screen. So identify the tens digit, and it is identified by the name that we have right there, and it's also identified by that arrow that we have right there. So what do we do next? We may go ahead of the computer, but let the computer go first. Now, we have identified the digit immediately to the right. It is a 5. We therefore add 1 to the tens digit. Why do we add 1 to the tens digit? We add 1 to the tens digit because if the next digit is equal to 5 or greater than 5, we add 1 to the tens digit. Because it is 5, we add 1 to the tens digit. So, is that good enough? Yes. So we're going to add 1 to the tens digit. If it is 5 or more, we add 1 to the tens digit. It is 5, so we add 1 to the tens digit. The tens digit is a 4, so we add 1 to that 4. What do we get? 5. Good. A 0 is then placed in the ones position as a placeholder. Why are you laughing, Jerry? We cannot always set a problem that will catch you, you know. I know that if we really wanted to catch some students, we could leave the answer as a 5. And that would catch a lot of students because they would not remember to put the 0 as the placeholder. Right? But not every problem can contain all the distractions in the world. Okay? And besides, it is so easy that you shouldn't need a distraction or a sensible distraction in this one. So let us move merrily on to the next problem. I'm sure that some problem in the long run will catch you even if there's no plausible distraction there. So the answer is therefore 50, and this represents option C. And Jerry, do not laugh at the problem. It is not so easy. Good. What type of numbers are 2, 3, 7, and 17? The first option is A, that says composite. So, if all the numbers are composite, then A is correct. So if we can find a number that is not a composite number in that set, then the option A is wrong. Now, what is a composite number? A composite number has other factors apart from itself and 1. So let us choose 3. The only numbers that can go into 3 are 1 and 3. We have proven that at least one of the numbers in this set is not a composite number. The set therefore cannot be a set of composite numbers. Because if a number is composite, it will have 1 itself and another number as factors. That means 1 can go into the number itself can go into the number, and we can find another number that can go into it without leaving a remainder. And that will make it composite. So, number 6, question number 6. The digits that we have here is not composite because surely this one is not composite. What about even? Option B, say even. Are all the numbers even? An even number can be divided by 2. Or, we should say, an even number is divisible by 2. That means 2 can go into that number without leaving a remainder. Even numbers end with 0, 2, 4, 6, or 8. Only one number in the set is even. Therefore, the set cannot be a set of even numbers. So, we have this set of numbers here. The only one here is even. So, the entire set cannot be a set of even numbers. Odd numbers are those numbers that are not divisible by 2. Divisible means that there is no remainder after division. So, the number 2 is in the set. 2 is an even number. Therefore, the set cannot be a set of odd numbers. Right? It cannot be a set of odd numbers because in that set, we have at least a single even number. So the even number in the set is 2. So the entire set cannot be a set of odd numbers. What about prime numbers? Each of the number in the set is only divisible by itself and 1. The set therefore represents a set of prime numbers. Why? Because prime numbers are only divisible by themselves and 1. The correct option is D. So all of those numbers are prime numbers. What number must be added to the product of 5 and 15 to make it 100? What do we need now, Jerry? Yes, Jerry. Are you telling me that we need to know what product means, or are you asking me what product means? Oh yeah, we need to know what product means. Okay, let us see what products mean. Let us first find the product of 5 and 15. A product is the result of multiplication. So 5 multiplied by 15 is equal to 75. Of course, we may work it out. 15 and we have our 5, and let us multiply and see what we get. How do we multiply? Say 5 multiplied by 5 is equal to 25. So we are going to write down the 5. So write down that 5. And what do we do with that 2 of the 25? We are going to carry that 2 to the tens column. And what do we say? All right, Jerry, you take it up from here. What do we say? Do we say 5 times 2? Or we say 5 times 1? What do we say? Well, the 1 is there already. Yes, the 1 is there already. So we need to say 5 multiplied by 1. And then what do we do? The computer is telling us what to do. So we say 5 multiplied by 1 is equal to 5. We now add the 2 that we carried, and the result is 7. So we say 5 multiplied by 1, and that is equal to 5. And then we add the 2 to 5, and we get 7, and it is right there. Well, it has to be the same like what we had before. So the answer is 75. So the answer is 75, but we need to finish answering the question. Did the problem require that we multiply 5 by 15 alone? No. It says what number must be added to the product of 5 and 15 to make it 100. So now that we have found the product of 5 and 15, we need to find a number that when added to 75, the result is 100. So we need to know the number that we will add to 75 in order that the answer will be 100. The number can be found by subtracting 75 from 100. So let us do it right there. 100 minus 75 is equal to 25. So no problem with that one. Not even Jerry will have any problem working that one out. Right, Jerry? Let me see the answer that you have. Oh, you have your 25 right there a long time ago. Good. But let us do it for real. So what do we do first? We cannot take 5 from 0. So 5 cannot be taken away from 0. So we go to the tens column, which is this one. What do we do there? There is another 0 in the tens column, so we move to the 100 columns. We rename the 1 by subtracting 1, and the result is 0. And what else do we do? The 1 from the hundreds column is placed in the tens column where it is 10 times the value. So 1 is placed right there. Do we say 7 from 10? Right, so I don't expect you to be exercising any memory loss right there, because our first job was to take 5 right there. And we have not done that yet. So we cannot say 7 from 10. We'll have to satisfy our requirements in the ones column first. So let us go there first. So we are going to rename that 10 that we have just created. And we write 9. And of course we have a 1 right there. So the 10 in the tens column is also renamed. So we get 9 and 1 is taken to the ones column where it is 10 times its value. So we have 10 now, and we say 10 minus 5 is equal to 5. Then now we may subtract the 7. And the 7 is subtracted from what? That number that we have right there. So 7 from 9 is 2. Or we may say 9 minus 7 is 2. And the 2 goes right there. And of course, we do not have any other number because right there is a 0. And there is nothing to be subtracted from it. The answer is 25. And this represents option A. Lovely. So, which is the same as 0.125. What do we do? The number of decimal places in the number tells us the power of 10 that we are dividing by. What do we mean by power of 10? We'll see that in a minute. So let us count the number of decimal places. The first one is the digit that comes immediately after the decimal point. So we are going to count the decimal places, and this one is the first one. This one is the first one. It is the first number that comes after the decimal point, so that is position number 1. So let us count those decimal places. 2, 3. Any more? No. So we know that we have 3 decimal places. All right. The power of 10 must have 3 zeros. The answer, therefore, is option C. The one that has 3 zeros. Because we have 3 decimal places, we need to have 3 zeros. So that is our answer. Now, this is what we mean by a power of 10. A power of 10 is a number that is equal to 10 multiplied by itself a number of times. Example, if we multiply 10 by 10, that's a power of 10. That's 100. So 100 is a power of 10. And if we multiply 10 by 10 by 10, we get 1,000. So 1,000 is a power of 10. And here's a very long one. 1, 2, 3, 4, 5. Good. So we have 10 multiplied by itself 5 times. And of course we have 5 zeros here. And that number is 100,000. What is 56 minus 0.56? How do we solve that one? When subtracting the numbers, the point must be placed under each other. 56 is a whole number and does not have a point. The point is considered to be to the right of the numbers. You know that I should ask you that one first, Jerry, before I put it on the screen? Yes, and see what you would say. Next time I'll remember to ask you before I put the answer on the screen. And I'll see if you really are alert today. So write down 56, showing the position where the point is considered to be. So we're going to write 56, and of course, the position where the point is considered to be must be indicated. Right there, good. So the point on a whole number is considered to be at the right of the number. Right, 0.56 with the point under the point. So 0.56 is going to be written now. If we're going to do that for 0.56, the point must go right there. And what is going to happen? The 5, 6 is going to be over here, and the 0 is going to be there. Let's hope. Good. So the point goes there, 5, 6 over here, and the 0 goes there. All right, I'm going to ask you a question now, Jerry, before I put the answer on the screen. So if we have 56 and we're going to subtract 0.56, How are we going to do that? With an empty space right here. Notice that we have an empty space right there. What do we do? Answer up now, Jerry. Good. Good boy, Jerry. We are going to use zeros as placeholders, right? Are we? Use zeros as placeholders in 56 so that we can subtract 0.56. You are right, Jerry. Even the computer is confirming that you are a very good student. We cannot take 6 from 0, so we attempt to rename the digit that is to the right. The other digit is a 0. Also, we therefore rename the 6. That's a mouthful, so let us see what that means. We are going to say 6 from 0. 6 from 0, Jerry. Good, we can't. So we are going to go to the next column and say 5. No? Good. So we're going to go to the next column and we are going to try to get something from this in order that we can put in this column. But when we get here, what do we notice? That we have a 0 again. And we are a little bit disappointed. So we go to this one. So this is not a 0, so we may rename this one. So rename the 6 and we have 5. Put the 1 right there and it is 10 times the value. So this is 10 right there. So do we say 5 from 10? Why not? Right, because we need to subtract the 6 first. So we need to rename that 10 that we have right there first. So we need to rename this 10 that we have right there. 9 right there. And of course 1 is taken down to the hundredths column. So may we go straight ahead and subtract now? Definitely. So 10 minus 6 is equal to 4. And 9 minus 5, or we may say 5 from 9. So 5 from 9 is also 4. So we put the answer right there. What do we do next? Sure, point must go under the point. So place the point under the point, right there. And what do we say? 0 from 5. If you have 5 apples and I do not take away any from you, how many apples do you have? You will still have that 5. Good. So we are going to put that there. And of course, we do not have anything there. Of course, we do not have anything to subtract from that 5, so it goes back right there. So what is the answer? 55.44. What option is that? That is option A. Now, this question is saying, what is the value of the 3 in 545.034? So what is the value of the 3 there? Now, I've placed a very large number with a lot of 9s there. Not because it is a requirement, but because by so doing, we can take a look at the place values. So that number that we have there is to show the place values. So let us do that. When reading the place value of a number, use the ones position as the central position of the number. So right there, the ones position is the central position. Do not use the point as the central position. Use the ones. That means ones is the center, and immediately to the left we have the tens, and to the right we have the tenths. So tens are to the left and tenths are to the right. There you have the tens to the left. To the right you have the tenths. Good. And of course, next on either side we have the hundreds to the left and the hundredths to the right. Right. And the thousands and the thousands are rightly placed on their respective sides. So they are right there, thousands and thousandths. Very good. The number that we have in the problem can be similarly labeled. So we're going to label the number that we have in the problem up there. What is the number that we have? You don't remember, Jerry? And it is right there. Come on, see? Right there. 545.034. Yes, that's the one that we are talking about. Isn't it? It should be. It is the one that the question requires that we take a good look at. So that's the one that we are going to use. Don't be blinded by the fact that we use this number here. That's not what the question is asking about. That number is placed there for you to see the place values. Do you see the place values? Answer, did you see the place values? Don't tell me that you're not blind. Okay, so you saw those place values. Well, we're going to use the same place values that you're looking at right there on the screen in order to determine the value of the 3 that we have right there. You figured that out already? What's the answer? Oh, that's very good, Jerry. The answer is 300ths. But let's see how we work it out right there. The number is written right there. And of course, we know the place values. This is ones. On either side, we have tens and tenths. And then we have what? Hundreds and hundredths. We do not have any thousand, but we have thousands. So, of course, there's no thousands position in this number. So we are going to say the thousandth position is going to be there. Good. And the 3, what is right over the 3? 300ths. And Jerry, you are very good. You got the answer long before I did. So the value of the 3 is therefore 300ths. This represents option A. Good. Some students mistakenly name the point as a central location. Do not make the same mistake. You might end up with the wrong answer. But you did not get the wrong answer, Jerry. You got the answer correct. And that shows that you're on your way to doing well in GSAT. Which set of numbers is factors of 24? So which set represent factors? So factors of 24 are numbers that can go into 24 or can divide into 24 without leaving a remainder. So what number do we have here that can go into 24 without leaving a remainder? Only 24. So in option A, 24 can go into 24 without leaving a remainder. A factor of a number must be smaller or equal to the number. So 48 and 72 are therefore out of the question. So a factor of 24 is a number that can go into 24 without leaving a remainder. And the only number in A that can do that is 24. The others are not factors of 24. So let us move on to option B. In option B, 8 and 24 are factors of 24. Why? Because they can divide into 24 without leaving a remainder. 16 cannot divide into 24 without leaving a remainder. Option B is therefore incorrect. Why? Because we need all the numbers in the option to be able to go into 24 without leaving a remainder. Each of the numbers in option C can divide into 24 without leaving a remainder. This is our correct option. Right there. 8 into 24 is 3, 12 into 24 is 2, and 24 can go into 24 one time. So we are sure that all those numbers are factors of 24. But is the other option incorrect? So let us satisfy ourselves by examining Option D. Ensure that it is also an incorrect answer. 2, 3, and 4 can divide into 24 without leaving a remainder. 2 into 24, 12. 3 into 24, 8. 4 into 24, 6. They are all factors of 24. However, 5 is not a factor of 24. It cannot divide into 24 without leaving a remainder. So 5 cannot go into 24 without leaving a remainder. How do we know that? Well, it's easy to identify numbers that 5 is a factor of. So 5 can go into only the numbers that end with 5 or 0. 24 it does not end with a 5 or a 0. So 5 cannot go into 24 without leaving a remainder. The catch to the question may be that students confuse factors and multiples. Option A contains multiples of 24. Multiples of 24 are those numbers that 24 can divide into without leaving a remainder. Multiples of a number are usually greater than or equal to the number. So the catch to this problem may well be that students cannot identify or cannot tell the difference between factors and multiples. But by the time we are through with this, no problem determining the numbers that are factors of 24. We have that as option C. What is 9% written as a decimal? Before we can tell, what do? We need to know what 9% means. Percent means out of 100. We may write 9 out of 100, which is the same as dividing 9 by 100. Now, you can take a look at percent, cent, century. All of those terms have to do with 100. So let us do that. Divide 9 by 100 by moving the point 2 places to the left. Jerry, what do? Remember, I said that if we have another problem like this, you'll have to tell me what to do. Write down the 9. What else? Right, it is a whole number. Because it's a whole number, what do we do with whole numbers? We put the point to the, make sure, is it right or left? Right? Yes, the point is going to be placed at the right. So do not forget that in a whole number, the point is considered to be to the right. Then what do? We are dividing by 100, Jerry. What do? Yeah. That's very nice. Move the points 2 places to the left, and there's only 1 digit, so we need to include another digit. That means you have learned from the other 2 examples, Jerry. Oh, that's a little bit showy, telling me that you knew the answer before we worked out the other 2 examples. All right, then. So we are going to move the point 2 places to the left. There's only 1 digit, so a 0 will have to be included in order that the point may be moved a second time. As usual, we have done that already twice. So Jerry Lewis is making use of the fact that we have done that already. Move 2 places, 1, but because we need another, we put 0, and we move the point 2 places. And of course, we may put a 0 in front. Right? And the answer is 0.09, and this represents option B. Good. This says, any number that has 0, 2, or 8 in its ones place is always, And the options are prime, even, odd, or composite. 0, 2, or 8. Therefore, all of those should satisfy the option. So, let us see what that really means. In option A, if we examine numbers that end with an 8 or even 8 itself, so is the number that ends with 8 or the number is an 8 itself, the number spoken about cannot be prime. There is no prime number that can end with an 8. So we know that that one is out. Option B. Option B is correct because all numbers that end with 0, 2, 4, 6, or 8 are even. So any number that ends with 0, 2, or 8 must be even. So option B is correct. Let us examine option C also to ensure that it does not fit. Now we know the answer, but let us ensure that C is wrong. The number 2 is a single digit and therefore has 2 in its ones place. The number is known as the only even prime number. This makes option D incorrect, as a number that has a 2 in its one place can also be prime. I need to repeat that, Jerry. You did not understand what I just said? Okay, so I need to take a look at it again. Now, option D is saying a composite number. Are all numbers that end with 0, 2, or 8 composite? By the way, what is a composite number? A composite number has 3 or more factors. One factor is the number itself. Another factor is 1, and it also needs to have another factor, else it is not composite. So a composite number must have at least 3 factors. Now let us look at a number that ends with a 2. Let us even look at 2 then. Is 2 a composite number? No. Why is 2 not a composite number? Because 1 can go into 2, which is 1, and 2 can go into 2, which is the number itself. There is no other number that can go into 2 or divide into 2 without leaving a remainder. Therefore, the number 2 is not composite. Therefore, this option is also incorrect. Good. A prime number is a number that is only divisible by itself and 1. This means that any number that is a prime number, only itself and 1 can divide into it without leaving a remainder. All other numbers are composite. So 2 is a prime number. So D, the option D that says composite, is wrong. Which of the options that we have there represents a finite set? What is a finite set? A finite set has, Jerry, can you tell me what that finite set is? Yeah, if we can write down the numbers in a set, then that set is finite. That is a good way to identify a finite set. As long as we can write down the numbers, all of the numbers that are in a set, then that set is finite. That is one way. But finite means that it comes to an end. Infinite means that the numbers or the elements in the set has no end. So we may keep writing numbers in this set and we will not be able at all to write down all the numbers that are in that set. We cannot identify all of them because it continues what we call indefinitely, that is without end. So our first one, fractions between 0 and 1. Does that represent a finite set? Option A is the one that most people will think to be the correct answer, because we have 0 and 1, and we need to write down the fractions between 0 and 1. So because we have a limit there, then it is said that this set has to be finite. The problem is that it is not finite. Why? If we write 3 as the numerator of a fraction and the denominator starts at 4, we may increase the denominator by 1 step by step and discover that all the fractions with 3 as the numerator can have infinitely many denominators. Option A is therefore incorrect. So if we start, say, 3/4, then 3/5, then 3/6, which is of course a half, then 3/7, then 3/8, and if we increase the denominator like that, we will realize that the number that we are going to be using for the denominator can keep on and on. We can keep increasing it by 1 all the time, and we will never be able to end it. So that causes fractions between 0 and 1 not to be a finite set. What about the next one? Points on a line. What we generally draw in our book and call a line is not a line. It is a line segment. A line being of infinite length will therefore have infinitely many points. Therefore, a line has no end. What we draw in our books is a line segment. So, because a line actually has no end, then the number of points that we have for a line has no end either. What about the set of counting numbers? That's another one. Look at option C. The set of counting numbers is infinite. Do not be deceived by its name. So because you can count, and you can count to a point and stop or end, that doesn't make the set of counting numbers finite. If you are even counting, stop as soon as you get fed up. So when you are counting, you may stop as soon as you get fed up. So no matter where you stop, there is always another number to go to. So you can name the largest number that you can ever name in the world. There is still another one that you can count to. So the set of counting numbers is infinite. What about counting numbers between 0 and 10? Of course, you have a limited number of counting numbers between 0 and 10. You have 1, 2, 3, 4, 5, 6, 7, 8, 9. It doesn't get more than that. So that's a finite set. And of course, if a set is finite, we can write down the numbers or the elements in that set. Any set of which we can write down all of the elements is finite. The set of counting numbers between 0 and 1, the set is what? 1, 2, 3, 4, 5, 6, 7, 8, 9. We can write it down, so that set is finite. D is our correct answer. Oh, now we are at the ones that many students hate. But what do you say, Jerry? Oh, you love mathematics. So you love every single problem that we are going to be working out, even if you get it wrong? I don't believe that you could love a problem if you get it wrong, Jerry. How can you love a problem if you get it wrong? Very good. Oh, so, right. You can learn how to do it the next time so that when you see it, you get it right. Good, good. So you love even difficult problems then? Right. Good. Yeah, more difficult problems make you a better mathematician all the time. So you don't mind getting some wrong. You learn from your mistakes and you move merrily along. That's a very intelligent answer, Jerry. Let's see if you can work this one out, Jerry. That will make you an even more intelligent person than I imagined that you were. Okay. So we are going to add the whole numbers first. So we have 2 plus 1 plus 2, of course, that is 5. And we are going to include the fractions. So we're going to add the fractions also. So how do we add fractions? To add the fractions, we need to find the LCM of the denominators. So we say, what is the smallest number divisible by 2, 5, and 10? So 2, 5, and 10 are the denominators. So what is the smallest number that 2, 5, and 10 can go into without leaving a remainder? 20. Jerry, I said the smallest. I did not say a number that 2, 5, and 10 can go into without leaving a remainder. I said the smallest. Can 10 go into 10, Jerry? Yes, 10 can go into 10. Right, that means 10 is the smallest one then. And it's the smallest one that we're looking for. Stop scratching your head. And let us complete the problem. So what do we say here? 2 into 10 is 5 multiplied by 1. So 2 into 10 is equal to 5. Then we say 5 multiplied by 1, and that is equal to 5. Then we're going to say 5 into 10 is what? 2. And then we say what? 2 multiplied by 1 is equal to 2. And then what? 10 into 10 is 1. Right there. And then 1 multiplied by 3 is equal to 3. So 5 plus 2 plus 3 is equal to 10. So 5 is the whole number, and here we're going to have 10 over 10. What is 10 over 10? 10 divided by 10 is 1. So 5 plus 1 is equal to 6. The answer is 6, and this represents option A. What is the LCM of 12, 8, and 24? Remember the question we just solved? Yes? Yes, Jerry. We found the LCM just now. But now we are going to show how we can find the LCM of some numbers, right? Good. Now, what does LCM mean? LCM means the lowest common multiple. So let us look at what each letter symbolizes right there. Lowest means that we are looking for the smallest. The common means that it is in all of them. And the M means that it is a multiple. So the number that we are looking for must be a multiple of all of the numbers. It must be common. Common means that it is in every single one of them. And lowest means that it is the smallest. But what is a multiple? What is a multiple of 12? A multiple of 12 is a number that 12 can go into without leaving a remainder. So let us look at that. Multiples of 12 are those numbers that 12 can divide into without leaving a remainder. Let us write down some multiples of 12. Can 12 go into 12? Yes. Into 24, 36, 48, 60, 72, and 84. So 12 can go into all of those numbers without leaving a remainder. So let us also write down the multiples of 8. Multiples of 8 are those numbers that 8 can divide into without leaving a remainder. Let us write down some multiples of 8. Eight can go into 8, 16, 24. It is similar that what we are doing here is similar to writing down the 8 times table. Right? So we have 8, 16, 24, 32, on and on. Let us also write down some multiples of 24. 24 is by far the largest number in the set. We therefore do not need to write many multiples of 24 because 24 is very, very much larger than the other numbers. So let us write down a few. 24, 48, and 72. Good. So 24 can go into 24 without leaving a remainder. 24 can go into 48 without leaving a remainder. and 24 can go into 72 without leaving a remainder. So those are multiples of 24. When looking for the lowest common multiple, we look for the numbers that are common to the three sets. So what numbers are there? What numbers we have here, here, and here? First number that we have is 24, 24, 24. So the numbers are 24, 48, and 72. So we have 24, 24, 24. So 24 is common. That means it is in all of them. What about another common one? Do we have another common one? 48, yes. 48 is in this, there, and there. Do we have another? 72 right there, and right there. So the numbers are 24, 48, and 72. They are all multiples. They are all common. Why are they common? Because they are all in the sets of multiples. And now we are going to look for the lowest. So what do? We next identify the one that is lowest in value. So which one is the lowest? The answer is 24, and this is option B. Very nice. If you see another problem with lowest common multiple, could you work it out? Tell me the truth, Jerry. Could you work it out? Well, this is a video that we are making, Jerry. If you do not understand every single thing in one shot, when I've created the video, you just play the video again and again, and you rewind it and take a look at it again. And by the time we get to the other video on the other problem papers, then you should be able to do it. You don't think? Come on, Jerry. Give yourself a good chance. You're a lot smarter than you imagine. If you see this happening a few more times, you should be able to master it. But let us use another method to find the LCM. In order to find the lowest common multiple, the numbers may be placed in a table and repeated division used. So we're going to put them in a table, and we're going to use what is called repeated division. So let us put them in a table. Good. Now, notice how the table is constructed. I've put a double line here to separate what we're going to put here from the numbers that we had to begin with. And the ones that we are going to be changing or dividing or modifying, we place them over here. And over here we have this double line that is going to separate what we have here from what we started off with. We seek a prime number to be used to divide the numbers. So if we are going to begin our set of prime numbers, it makes sense that we begin at the smallest prime number, which is 2. Can 2 go into any one? If 2 can go into any of these, we may use 2. So if 2 can go into 8 or 12 or 24, we may use 2. The beauty of it is that 2 can go into all of them, so we are sure that we can use 2. 2 can go into at least one of the numbers, so we may use it. So what do we say now? 2 into 8 is 4. 2 into 12, 6. And 2 into 24, Jerry, 12. What do we do next? Next, we may use 2 again and continue until there is no number that is divisible by 2. The numbers that are not divisible by 2 are written down in the next line. So what do? We are going to use 2 again. Why do we use 2 again? Because 2 can go into at least one of these numbers. Say 2 can only go into 4. We will still use 2. But what do? 2 into 4, 2. 2 into 6, 3. 2 into 12, 6. Can we use 2 again? Yes. Because 2 can go into 2 and it can go into 6. So what do we do now? 2 into 2, 1. 2 into 3, 2 cannot go into 3 without leaving a remainder. So we are going to write the 3 down. So any number that cannot divide evenly, we are going to leave it to be divided by the next prime number. So because 2 cannot go into 3, we are going to put 3 down here. So we're going to use the other prime number on it. And 2 into 6 is 3. So, notice here that there's no number here that 2 can go into without leaving a remainder. So we cannot use 2. We move to the next prime number. When we are finished with 2, we may move to the next prime number, which is 3. There's at least one number that is divisible by 3, so we may use it. Of course, 3 can go into 3 right there. So what do we say? It cannot go, so we put the 1 there. 3 into 3 is 1, and 3 into 3 again is 1. So since we have 1 in all of those, then we know that we cannot use any other number. Because we cannot use any other number, we may go straight ahead and find the LCM. There. So the answer is found by multiplying the prime numbers used in the division process. So in the division process, these are what we use. So we're going to multiply these together. So what do we say? 2 multiplied by 2 multiplied by 2 multiplied by 3, which is the same thing that we have here, and that is equal to 24. And this represents option B. And it is the same like the one that we have just calculated. So if 0.1 is squared, what is the answer? What do we mean when we say we square a number? You think I'm joking, Jerry? We are squaring a number. We're not talking about a four-sided figure now. So when a number is squared, it is multiplied by itself. So let us multiply that number, which is 0.1, by itself. Now, we have a serious problem here because we have decimal places. So, what do? In the multiplication process, we may neglect the decimal places until later. So, we're going to say 1 multiplied by 1. So, we multiply 1 by 1, and the answer is 1. In order to know the number of decimal places in the answer, we count the number of decimal places in the problem. So we are going to have decimal places in the answer because we have decimal places in the problem. But the number of decimal places that we have in the answer is the same as the number of decimal places that we have in the problem. So we have 2 decimal places in the problem. The number of decimal places in the answer is going to be equal to 2. So the answer must also have 2 decimal places. 1 is a whole number, and the point is assumed to be to the right of the number. And of course, we need to move 2 places to the left as usual. So we need 2 decimal places. The point should be moved 2 places to the left. There's only 1 digit, so we include a 0 in order to complete the required number of decimal places. So the required decimal places is 2, so we include a 0 in order to complete the number of decimal places, which is 2. And of course, we may put a 0 at the front. So that answer is 0.01, and that represents option C. What is 618 written in exponential form? 100 that we have here is actually 10 to the power of 2. So 10 to the power of 2 is equal to 10 multiplied by 10, which is equal to 100. The exponential form of 100 is therefore 10 to the power of 2. So the exponential form of 100 is therefore 10 to the power of 2. What about 10 to the power of 1? That is equal to 10. The exponential form of 10 is therefore 10 to the power of 1. Any number raised to the power of 0 is equal to 1. And this applies to 10 also. The exponential form of 1 is therefore 10 to the power of 0. So write down the number 618. So let us write that down first. And let us put in the place values. The place values are there. hundreds, tens, and ones. But do not forget ones. What is the exponential form of 1? 10 to the power of 0. What is the exponential form of tens? 10, which is 10 to the power of 1. And the exponential form of 100 is 10 to the power of 2. So replace the regular place values with their exponential form. So we have the regular place values here, and we are going to replace them with the exponential form. Good. So we may write down then 618 in exponential form. So the answer may now be written in exponential form. 6 to the power 6 and the 10 to the power of 2. So 6 multiplied by 10 to the power of 2. 1. 10 to the power of 1. What about 8? 8 is accompanied by 10 to the power of 0. So we have 8 multiplied by 10 to the power of 0. And what is that? The answer is option D. There it is. Which shows the number with 7 in the tens place, 3 in the thousands place, 2 in the ones place, and 8 in the hundreds place. This problem kind of caused the thing to be a little bit jumbled, right? So it is not in order. So what do? Of course, we create the order ourselves by putting a template. We are in computer age, so you have to know what is a template. What is a template, Jerry? Some boxes that you put information in. A template may be in the form of empty squares or circles, but it has to be like some form in which information is placed. So let us put a template now. Let us draw a template in which the ones place is the largest, because up there we have the ones place is actually the largest. And which one is the smallest? The thousandth place is the smallest place value. So the ones place is the largest place value, and the thousandth place is the smallest place value. 1 is the largest, and thousands the smallest. So let us do that. Notice that we have the ones, tens, hundreds, thousands, right? And we are going to look at the question. Insert the digits in their appropriate place as required by the statement of the question. So we're going to look at the question. See 7 in the tens place. So the tens place is right there, so we're going to put 7 right there. The next block says what? 3 in the thousands place. So 3 is in thousands place. What do? We put 3 in the thousands place. And the next one says what? 2 in the ones place. So in the ones place, we put 2, and then what? 8 in the hundreds place. Good. See? That's very nice. We don't really have to be confused by that. And we have our answer. So in a problem that the thing is not in any order, we are required to create the order by ourselves. And we are in the computer age. Templates may be used, and see, we have used a template or a form. Very nice. The answer is option B. This question says, Jerry, which shows a pair of equivalent fractions. How do we know when fractions are equivalent? Well, we can determine if they are equivalent if we reduce them to their lowest terms and they are equal. So to determine which of the pairs represent equivalent fractions, reduce the fractions to their lowest terms. If after reducing them to their lowest terms they are equal, then the pair represents equivalent fractions. It's as easy as that. Well, let us see if it is as easy as that. Let us reduce that one. Can this be reduced? No. Can this? Yes. So in option A, the first fraction is in its lowest term, which is 3 over 5, or 3/5. The second one may be reduced by a factor of 2, which is 4/6. So when we reduce 4/6 by a factor of 2, 2 into 4 is 2, and 2 into 6 is 3. Are they equal? No, they are not equal. The resulting fractions are not equal. Option A is not correct. What about that one? What about those? Right, Jerry. They are not equivalent fractions because they are in their lowest terms already, and they are not equal. So the fractions in option B are already in their lowest terms. They are not equal. Option B is eliminated. What about C? 3 over 5 and 12 over 20. So 3/5 and 12/20. The second fraction in option C can be reduced by a factor of 4. Yes, 4 can go into 12 without leaving a remainder, and 4 can divide into 20 without leaving a remainder. So we are going to say 4 into 12 is 3, and 4 into 20 is 5. Good. So what do we know about question 20? The fractions are equal. Therefore, the two fractions that we started off with are equivalent fractions. So the resulting fractions are equal. Option C is correct. Good. 3 over 5 and 5 over 3. What do you know? The fractions in option D are already in their lowest terms. They are not equal, and option D is shown to be incorrect. So that's what we have. That fraction, those two fractions are incorrect. So Jerry, good assistant you were today. We have finished our first part, which is questions 20, question 1 to 20, and that is part A. So let us move merrily on to part B, questions 21 to 40.